Welcome, my dear student. So today I am taking one of the important topic in physics. So how to take element. So this is the most common topic applied for different chapter in physics. You will encounter that in different topics under the class 11 or class 12. So most of the student bothers take how to take the elements and where to take the elements or how to apply the concept of integration. Okay. So it is nothing but the general tool used in physics. Almost all the chapters in that particular physics subject cover this. Okay, so this is the first part of the video. So in the next part, I will going to explain the different applications. So today we learn how to take the different types of element. Okay, so first topic is when to take the element. First is when to take the element. So whenever you encounter in such a situation where there is something is variation. So there may be variation in mass, there may be variation in density, or variation of charge. Like that way, in those things, you have to take care about the element. So once I take the element, then our task is to how to take the element. So there are different methods to take the element. So in physics, mostly we will deal with at least 6 to 8 number of elements. Now, once I take the element, now the next part is to how to integrate it. Now, while the integration, I have to perform the definite integration. That means I have to put the limit also. So these are the three major issues that will be deal in this particular video. So stay tuned till the last of the video. So you will understand complete thing about the integration part that is being applied in different topics of physics. So regarding the different topics, so almost all topic in the class 11 or class 12 chapter consider the application of this element. So like the center of mass, now whenever I want to calculate the position of the center of mass, it is R center of mass. Okay, so I have to apply the concept of this. For the rotational motion, calculation of the moment of inertia or torque, I have to apply the concept of integration. In gravitation, I have to apply this gravitation. So whenever I have to calculate the gravitational field or the potential value, okay, so I have to apply the concept of the element. In case of fluid also, I have to calculate the pressure. I have to calculate the pressure. What is the pressure offered by the fluid surface on a particular fluid medium on a particular surface. So in that situation also you have to apply the concept of this integration. So thermal properties, there are some application where I have to calculate the thermal resistance. So then I have to take care about this element. Or in case of conduction parameter also I have to take about this element. There is some application in wave motion also. Electrostatics and capacitor, lots of applications are encountered under this particular chapter where we have to calculate the capacitance or where we have to calculate the electric field. In case of current electricity, so you have to take care about the calculation of the resistance. So the thermal property, so here I am going to calculate the thermal resistance. Similarly, here under the current electricity chapter, I have to calculate the electrical resistance. So both are almost same. Calculation procedure is almost same. So in those situations, I have to apply the concept of integration. In magnetism, under this chapter, you have to calculate the magnetic field. In EMI also, for calculation of flux also. Okay, so different techniques are there. So different chapters are there. Some amount of calculations are also encountered in the ray optics chapter. So these are the very basic chapters where we have to apply the concept of taking how I am going to take the integration in this particular situation or how to take the element. All those techniques are to be dealt under this particular chapter. So you can clearly see that almost all the chapter under the class 11 and class 12 covers this concept. So that concept is going to be very crucial for you. So unless and until you get the comment on this particular topic, you cannot do a higher level problems on this particular following chapter. So basic problems can be solved without the concept of integration. But whenever I go inside the problem where I have to apply this concept, so mostly for the higher level problems, I have to apply the concept of integration. So without any further delay, let us start this session. So these are the different types of element I am going to discuss under this particular lecture. First is the rod element along the length. So this is basically the 1D element. So both 1 and 2 are the 1D elements. So whenever the geometry is 1D, then we should go for this type of element. Then there is a part of a disc. Hollow hemisphere 3 and 4 are basically the kind of element which are 2D element. And solid hemisphere or sphere and cubical solid or hollow cone, custom cone. So these are the typical some kind of element that have to be taken care under the case of situation where we deal with the 3D type of element. So mostly we will encounter by this type of elements. Okay, that doesn't mean that in mathematics under the integration chapter I can only take this kind of elements. So there are numbers of elements. There are a number of elements that you can take different types of element. So there is a lot of nature of element, different types of element that can be taken. But for physics, I should only consider this type of 6 types of element which can be applied on solving of different types of problems. So let us start the first application where I am going to take the rod. So means along the length of that. So the first element. So generally in such questions, a parameter like linear mass density that is defined by the lambda or linear charge density is given. So you are asked to calculate the total charge. What is that? So for that you have to take the moment move by distance of x from the one end and take a element length of dx. Okay, take a element length of dx. So now I want to check what is the elemental charge inside that. So let us say I want to get the value of dq. So for that I should define the value of lambda. What is lambda? Lambda is the charge density defined in coulomb per meter. So once the lambda parameter is known, so what is the small elemental charge that's stored inside that particular element? That is nothing but what? Lambda into dx. Okay. Now what is lambda? Lambda is let us say in this particular rod the total charge is given as q. So this can be written as q by L into dx. So that is the small charge that comes into this element. Similarly, if I want to calculate the small mass of this element, let us say I want to calculate the dm, elemental mass. So for that again I have to define the value of lambda. Now in this particular situation, what is lambda? Now here the lambda is nothing but in kg per meter unit. That is the linear mass density. Multiplied by delta x or dx. Okay, so in all of this situation, I have to take about this, consider this element. So elemental mass or elemental charge you have to define. So for that the lambda parameter has to be defined. So lambda number may be constant, may be variable. So if it is a variable, so that variation should be given in terms of the x parameter. So depending on that, I have to take about this element and then I have to go for the calculation. So whatever the calculation, that may be the field calculation, that may be the moment of inertia calculation. Okay, so different types of calculations are there. So I can apply this concept. Now moving on to the next type of element, that is the arc of a circle. So for arc of a circle, what you have to do, you have to go for theta angle. So once I rotate by an angle theta, then you have to take the element d theta. So this angle is d theta. Corresponding to this is our element. This is our element whose length is r d theta. This length is r d theta. Now let us say here also the lambda is defined. Lambda is defined in terms of coulomb per meter. So what is this lambda then? So for this particular element, what is the dq then? dq should be equal to lambda into length. Length of the element is r d theta. Okay. Now regarding the lambda number, what is the value of lambda? Lambda is the total charge. Let us say q is the total charge given divided by perimeter. So perimeter is 2 pi r half. Half of 2 pi r, that is pi into r. So that's why this is the value of lambda. So corresponding to that, you can calculate the value of dq. Once you get the dq, then you have to integrate it. So once you are integrating it, so here the limit will be from 0 to pi. Right? Here at this point, theta is equal to 0. Now, once I take the element at the extreme situation, so here the theta becomes pi. So limit of theta should be, because integration has to be done in terms of theta. Okay. So once I put the limit, so limit is from 0 to pi. So it may be a complete half circle or it may be part of half circle. So once the part of half circle is there, then the limit will be changed. Then the limit will be changed. So for this particular situation, what is the limit? From this vertical axis, I move in this direction by angle theta naught. I move in the opposite direction by angle same theta naught. Since the direction of movement are both different, so here the limit should be equals to, from here the minus theta naught to plus theta naught. So here the integration limit should be minus theta naught to plus theta naught. Okay, so this is for the arc of a circle, not a complete semicircle. Okay, now moving on to the next situation. Now part of a disk. So for disk element, how to take the disk element? So here you consider the ring element. So by moving a distance of r, I take a small ring of thickness dr. Okay. So now we have to calculate the area of this ring. Why? Because for this situation, I should define the sigma parameter. What is sigma? Sigma may be kg per meter square, that may be areal mass density, or it may be charge density. So coulomb per meter square, that may be given to you. Okay. So once sigma number is known, so I have to calculate what is the area of this element. Now what is this area? So that let us say that is dA. So if we straight it, if we make it straight, so it becomes a rectangular element like this, whose thickness is dr. Whose thickness is dr? Because I take the element by moving a distance of r from the center and taking the thickness of the element as dr. Now what is this length? So length is the half of the perimeter. That means pi r. Half of the perimeter is pi r. So in this situation, so this area becomes our dA. So what is this dA? That dA should be equals to pi r times dr. So once I got the information of the dA, now I can calculate what is the small dq charge that is there. So what is the dq? That should be equal to sigma times dA. Okay. So you know the value of sigma, you know the value of dA. So you can calculate the dq number. So once you formulate the dq parameter, now your task is to put the limit. So here the variable is r, because the integration has to be done under the r variable. So against r you are doing the integration. So r limit is varying from 0 to capital R. So what is the capital R? Capital R is the disk radius. So here you have to put the limit from 0 to capital R. Okay. Now that is the part of a disk. Now if I take the complete disk, then the limit will be changed. Not only that, but again the elemental shape is also changed. So here I am moving by the same r distance. I am taking the element of dr thickness. So now once I open it, so now the rectangle becomes like this way. Okay. So here this is dr, but now this length is total perimeter. So that is 2 pi r. Okay. So this is 2 pi r. So area of this ring element should be how much? Now the dA number is changed. Now what is the dA number? dA number should be equal to 2 pi r into dr. Okay. That is the dA number. So once I got the value of dA number, then you can calculate the dq also. Same logic. In this situation, dq should be equal to again sigma into dA. Again the variable is r. So what is the limit then? Limit is from 0 to capital R again. Okay. Here also the limit will be from 0 to capital R. So this is the second type of element. So both are basically disk element, or I can say it is a 2D kind of element. Now come to the next, hollow sphere. So hollow hemisphere. So in case of hollow hemisphere, how we have to take the element? By moving a theta distance, we take an element of d theta and take a element like this. So this element is nothing but a ring element. So this is the ring element. Okay. So for this ring element, so what is the width of the ring element? That is r times d theta. R d theta is the width of the element. Now what is the radius? So if I say this is a small radius, that has been the radius of the ring, r. So what is r? Small r is basically r sin theta. So small r equals to r cos theta. So this is a smaller number, that is r cos theta. Because I am taking the theta from this x-axis. So small r becomes r cos theta, that is our radius. So what is the total length of the ring? So if I cut the ring and make it horizontal, so now this becomes 2 pi smaller. 2 pi smaller. And this distance is not dr, it should be equals to capital R times d theta. Okay. Now what is small r? Small r is r cos theta. So I can simply write it is 2 pi capital R into cos theta. So what is this area? That area is equals to 2 pi capital R cos theta multiplied by r d theta. Okay. So here the area dA becomes how much? dA should be equals to 2 pi capital R square cos theta into d theta. Okay. So integration becomes as a function of theta. Now you have to do the integration as a function of theta. So once we find the small area dA, now you have to put the limit on theta. Now what is the variation of theta? So theta will start from here, from 0. So ultimately the theta has to move up to this point, pi by 2. So limit of theta should be equal to 0 to pi by 2. So once I take one element, so it will complete the entire hemisphere. Okay, so that means only thing is that you have to move from 0 to pi by 2, not 0 to pi. Okay, because I am taking the element, so it will the entire, it will cover the entire hemisphere. So you have to take the element between limit from 0 to pi by 2. Now, if the situation is solid sphere, if the situation is solid sphere, so it may be the solid hemisphere. So let us say solid hemisphere. So again, you have to take a hemispherical element. So it is a hemispherical element. So what is the hemispherical shell? It is called the shell element. Why shell? Because I have taken the concept that dr is very, very small. Once dr is very, very small, so now I have to take about this volume. So what is the elemental volume? How to calculate that elemental volume? So that volume is basically the surface area multiplied by dr. So what is the surface area? 2 pi r square. So 2 pi small r square into dr. So that is the formula for the volume. So once I calculate the volume, Now in this situation, you have to define the value of rho. What is the rho? Rho is the mass density, volumetric mass density, or volumetric charge density. So let us say rho is given in terms of coulomb per meter cube. So what is that in elemental charge dq inside that small shell volume? So that is nothing but our rho into dv. So again, the dq becomes a function of small r. That means integration should be done against the limit of small r. So what is the limit? Here the limit is from 0 to capital R again. So small r limit will be from 0 to capital R, because small r is varying between 0 to capital R. Okay, so this is kind of 3D element. This is a kind of 3D element. Now moving on to the solid sphere. If I consider, instead of hemisphere, if I consider a solid sphere, so this type of element you have to take. So it is what? It is basically you are moving a distance of r, then you are taking a shell of dr thickness. So it is a hollow sphere. It becomes a hollow sphere. Because entire geometry is solid sphere. So once I take the element, I have to take an element as a hollow sphere. So when you are taking the element as hollow sphere, so now the volume is how much? So here the dv volume should be equal to area. Area is surface area is 4 pi small r square multiplied by dr. Okay, that is the concept you have to apply to calculate the volume of this hollow sphere. So once I calculate the volume, next task is to write the dq charge. Okay, or dm mass multiplied by rho. So once I multiply by rho, so I can get either the elemental mass or the elemental charge. So it depends on the nature of the problem, what you have to calculate. So once you write the dq or dm, now you can find that it is a function of r. So here the limit will be from 0 to capital R. Okay. So 0 to capital R will be the total limit for the r. Okay, moving on to the next situation where I am taking the cuboidal element. So for cuboidal element, you have to move a distance by x and take an element of dx. So now this becomes the small element. Now what is this height? Height becomes h. And what is the length? Length is b. Okay. So in this situation, the volume should be how much? Volume should be equals to b into h into dx. Okay. B into h into dx. So that is the volume. So once I calculate the volume, so now I can calculate either mass or charge, depends on the nature of the problem. Only thing is that you take care about the limit. So here variation is with respect to x. So x is varying from 0 to capital 0 to L. So you have to put the limit from 0 to L. Okay. So this is the kind of element which is again the 3D kind of element. So here I am calculating the volume. Now moving on to the next situation where I have to take about the hollow cone. So for the hollow cone and solid cone, there are two different types of elements. For hollow cone, it is the most interesting type of element and most complex element. So out of all those geometry, this is the most interesting type of element. So where you have to move from the vertex. So once you move by a distance of vertex x and then take the element of dx. Okay, so once you take this element, so now this elemental shape will be a ring whose radius is smaller. Let us say I am taking the smaller radius. Okay, now apply the concept of similar triangle between the upper triangle and the lower triangle. You can calculate the smaller value. Let us say I am taking this distance as y. This distance is y. So for this situation, smaller y capital R should be equal to how much? Y divided by, let us say, total height of the cone is 8. So y by 8. So that means R becomes capital R y by 8. Okay, so R is function of y. Now, regarding this y number, I can say that it is a function of x also, because y is nothing but x cos theta. Y equals to x cos theta. Y equals to x cos theta. So if we put it over here, so R becomes a function of x. What is theta? Theta is a semi-vertical angle. So that number is constant. So once I write the y number as a function of x, so now your task is to write the area of this. So once you open this ring, so it has a length of 2 pi r. If I open this ring, so length is 2 pi r. Length is 2 pi r. But mind it that thickness of this ring should be equal to dx. Thickness of the ring is dx. Okay, once you take the 2 pi r into dx, that will give the value of area. So dA should be equal to 2 pi small r. So under the small r, that is capital R y by h. Capital R y by h. Okay, and dx is there. So ultimately, now replace the y number by x cos theta. So dA becomes how much? dA becomes 2 pi capital R x cos theta by h into dx. Okay, so ultimately area becomes a function of x only. Okay, area becomes function of x only. So once you calculate this area, next you can calculate either the elemental mass of this element or charge of this element. Okay, so entire thing is a function of x. So you have to put the limit of x. So once you are doing the integration, your limit will be from 0 to capital X. So that will be your limit. Okay. So mind it that whenever you are taking the hollow element, so length should be along the length. So dx is nothing but the width. But for the solid element, once I move by distance of y, take an element of thickness dy. So it becomes a disk. It becomes a disk. Okay. So of radius smaller. So what is the volume of the disk? Can I say the volume dv should be equals to pi into r square into dy. Here the thickness is dy. In this equation, you don't have to take the slant length. So only thing is the vertical length is dy. So dv becomes pi r square into dy. Now what is r? R can be again written as pi into capital R y by h whole square into dy. Okay. So that means now the dv becomes function of y. In this equation, dv becomes function of y. So you have to put the limit of y. So y limit starts from 0 to h. So limit will become 0 to h. Okay, so this is the difference. So for the solid cone, you have to take the vertical length as the length of the element, that is dy, that is the height of the element. So, but in this equation, for the hollow cone, you take the slant length as the length. Okay. Now, next element may be the frustum of a cone. So, there may be a cone whose radius, inside radius is R1, outside radius is let us say R2. So, radius is changing in a linear way. So, by moving a distance of x, you have to take about this element. So, once I consider this element, your task is to calculate the small r. So, if I join a triangle like this way, if I draw a triangle like this way, if I draw the horizontal line from this point, so this length becomes r minus r1. Okay, this is x and this is r2 minus r1. So these two triangles are similar triangles. So from this, what I can say, r minus r1 divided by r2 minus r1 should be equals to x divided by l. Okay, so from this equation, I can calculate the smaller number. Okay, smaller number. Now what is the smaller number? Smaller should be equals to r1 plus r2 minus r1 by l into x. That is the r number. So once I calculate this r number, that is the radius of this element. So this is the disk element. So this is a disk kind of element. So you have to calculate the volume of this disk element. So how to calculate the volume then? So for calculating the volume, width of the element is dx. Radius is known. So for this element, what is the volume? dv should be equal to pi small r square into dx. So from here you put the r parameter. So r is a function of x and integration is also as a function of x. So that means you have to put the limit for x. So what is the limit for x? That should be from 0 to capital L. So here the limit should be 0 to capital L. Okay. So this is how you can take the element. So this is all about the different types of element. So in this video, I am going to discuss about only the different types of element that are mainly applied in case of physics. Okay, we mainly focus on this type of element. In the next video, I will encounter some of the application of this. How to apply the concept of this element to solve the problems. So different parameters like the moment of inertia or the torque or the center of mass or charge, field. Okay. So different parameters can be calculated based on this concept of taking the element. Okay. So if you understand this, if you like it, please subscribe my YouTube channel and stay tuned for the next video. Until then, bye.